All right, let's review Unit 3. First question says, what group number and group name does number 35 bromine belong to? So we go over to bromine. We see that it's right here where my cursor is in group 7A. So I'm going to go ahead and make this red. Group 7A, they are called the halogens. I think there's another spot where we'll review all of the different names. Is it a metal, a nonmetal, or a metalloid? Well, you have to look at this zigzag. Things to the left of the zigzag are metals, other than hydrogen. Things to the right of the zigzag are nonmetals, like bromine. And things that border the zigzag are metalloids. So in this case, bromine is a nonmetal. List any 3 elements that are transition metals. I could list anything in group B. And I'll highlight group B. So group B is right here. So it's all of these. So for example, I could be fun and choose some valuable metals like copper, silver, and gold. Example, Cu, Ag, Au. Give one example of a metalloid. So again, we're doing something that borders this zigzag. So boron would be a good example. Name the family that each of the following elements belongs to. Fe, iron. Fe is right here, number 26. So it says so right there. It's in the transition metals. Group B. Cl, chlorine, is actually right above bromine. So it's also in group 7A. Which would be the halogens. Krypton is right here. It's in group 8A. They are known as the noble gases. Strontium is right here in group 2A. Group 2A is known as the alkaline earth metals. And last but not least, lithium is right here, number 3. That is in the alkali metals. Those are group 1A. For number 6, it says we need to identify if each of these is an element or a compound. An element is always one uppercase and one lowercase if it's not just one uppercase. And a compound is at least 2 uppercase letters. So capital N, capital I, that would definitely be a compound because it's 2 capital letters. It's in fact nitrogen and iodine. Capital N, lowercase I would be an element. That would be nickel. Capital C, capital O, that's at least 2 capitals. That's another compound. While capital C, lowercase o would be the element cobalt. 2 oxygens would also be an element because it's not 2 different ones. A better name, we call it a molecule. All right. Can you describe the location, charges, and relative masses of the 3 subatomic particles within an atom? And can you identify the number of protons, neutrons, and electrons given an element's symbol and a periodic table? Okay, so as a little review, in the nucleus of an atom, there are protons, which have a positive charge, and neutrons. Electrons are in the shells that orbit the nucleus. Protons and neutrons weigh 1 AMU, and electrons weigh very, very little. It's considered negligible. So let's take a look. Fluorine, we know, is chemical symbol F. And it says that it's number 9, which means that it has 9 protons and 9 electrons. That always matches in its neutral form. Average atomic mass, we've got to check it out. Fluorine is 18.998 according to this periodic table. If you used a different one, that's okay too. And grams per mole. Most common mass number, that would round to 19. And the most common number of neutrons would be 19 minus 9, so 10 neutrons. How many positively charged particles, the number of positively charged particles this atom has in its nucleus. Positively charged particles are always in the nucleus, so this again would be 9. And number of negatively charged particles this atom has, which would be outside the nucleus, would be 9. Let's do the same for strontium. Strontium is number 38. It's right here, 87.62. I'm going to record that mass, 87.62. Its symbol was SR, number 38, so it's got 38 protons and 38 electrons. 87.62 rounds to 88, and neutrons is 88 minus 38. So we'd have 50 neutrons. And again, it would have 38 positive protons in the nucleus, and it would have 38 negative electrons outside the nucleus. All right, magnesium is number 12, so it has 12 total electrons. How many shells? Well, the period number tells you how many shells. So for magnesium, it's in period 3. And magnesium, if we check, is in group 2A. The group number matches the number of valence electrons, while the period number matches the number of shells. So magnesium has 2 valence electrons. Iodine, number 53, has 53 total electrons. Iodine is right here. And so it's in period 5. And I see that it's in group 7A. Perfect. I can predict properties based on its location, which ones would have similar reactivity, the smallest radius. Okay, so let's do number 9 first. Which element, magnesium, number 12, or aluminum, number 13, has a smaller atomic radius? So magnesium's right here, aluminum's right here. So while both Mg and aluminum have 3 shells of electrons, aluminum has 1 more proton in the nucleus than magnesium does. Therefore, this extra positive charge pulls the 3 shells of electrons a little tighter. I'm not going to say pulls, I'm going to say attracts the 3 shells of electrons closer to the nucleus, making aluminum have a smaller atomic radius. Which would have a higher ionization energy? Ionization energy is the energy required to remove an electron from an atom. Because aluminum has a smaller atomic radii, the electrons are closer to the attractive nucleus, and would be more difficult to remove, thus making it have a higher, excuse me, ionization energy. Name any elements that would react similarly to number 12, magnesium. Magnesium would react similar to anything in group 2A. So Be would be another great example. Anything in group 2A, example, Be. Number 10. There are two common isotopes of argon, argon-38 and argon-40. Based on the periodic table, which is the most popular? Well, let's go look at argon. The average atomic mass is 39.948. That means that argon-40 is the most common because it's closer to argon's average atomic mass on the periodic table. All right, chlorine-36. How many protons would it have? Well, chlorine is number 17, so it has 17 protons. Neutrons is the mass minus the number of protons. So let's see, it's the end of the day, my brain is fried. 36 minus 17, 19. Silicon 30 would have 14 protons, and 30 minus 14, that's 16 neutrons. This one has 11 protons, so you have to look up which one's number 11. That's sodium. So this one's name would be sodium dash. Its mass is 11 plus 13, because mass number is the number of protons plus the neutrons. And its symbol, sodium, is Na, and it would have a 24 in the upper left and an 11 in the lower left. Complete the following Venn diagram for nuclear fusion and nuclear fission. Well, they both release energy. Nuclear fission is when you bombard a big nucleus and you cause the nucleus to split into two smaller ones. So large nucleus is split. These products are radioactive. Products are radioactive. Nuclear fusion, on the other hand, is when two small nuclei fuse together to make a new, larger nucleus. So the product is not radioactive. And you could get into some more detail here. Maybe you said nuclear fusion happens in the sun and the stars. Nuclear fission is man-made. We use this in power plants, atomic weapons, although both are used in atomic weapons. They have not quite figured out nuclear fusion power plants yet. All right, fill in the missing information. This I can identify as a beta decay. Now I have to think backwards here. What was it before if the atomic number went up by 1 to get to 76? It must have been 75. The mass would still be the same. So I've got to go look up what element is number 75. That's Re. This next one I'm recognizing as a beta decay. So it's going to lose a mass of 4, and it's going to lose 2 protons, 103 minus 2. And 101 is MD. and a lithium. Letter C, I recognize as a fusion because it's the plus sign before the arrow. So 49/24. And then we got to look up what element is 24, Cr, chromium. So we've got an beta decay, we've got an alpha decay, and we've got a fusion. List one benefit and one hazard related to nuclear chemistry. Let's see. Nuclear power is clean energy, no carbon emissions. One hazard is the radioactive waste that has a long half-life. So it takes a long time for it to become safe to be around. 1 mole of helium has a mass of about what? Well, the periodic table will tell us. Oops, let's find a periodic table. Okay, helium, 1 mole of helium atoms weighs about 4 grams. Write in the molar mass in grams for the following. Calcium is 40.078 grams per mole. And what would CaF2 be? Well, we got to look up F. I think it was 18.998 on this one. So 18.998 times 2. Oops, why is this not cooperating with me? Okay, and then we want to do that 37.996 plus 40.078. And that is 78.074 grams per mole. We can always double check by doing molar mass, CaF2, 78.07. Yep, nice. Which has more atoms, 10 grams of barium or 10 grams of Mg, magnesium? Well, let's see. Barium has a mass of 137.33 per mole. Grams per mole, and Mg is like 24.31 grams per mole. So Mg atoms are smaller. So if you have 10 grams of magnesium atoms, then you would have more magnesium. There are more atoms in 10 grams of magnesium than there are in 10 grams of barium because magnesium atoms are smaller, so it takes more of them to add up to 10 grams. Last, there's a few dimensional analysis inversions. 40.0 grams of Fe. How many moles of Fe is this? So 1 mole Fe is how many grams? 55.845. And I'm going to use my OneNote calculator. And I want to round to the correct number of significant digits, which is 3.716 moles of Fe. If you're getting ready to perform an explosive reaction and you need 2.5 moles of sodium, how many grams is this? Well, 1 mole of sodium is equal to 22.99 grams. By the way, I forgot to cancel out on that last one. So we got 2.5 times 22.99. We want two significant digits, 57 grams of Na. If I scraped 0.35 moles of iron 3 oxide off of some rusty nails, how many grams of that? Well, how much does 1 mole of Fe2O3 weigh? I'm going to have to add this up from the periodic table. So Fe was 55.845 times 2 of them. Oxygen is 16. So that's 111.69 plus 48. That's a total mass of 159.69. Multiply everything on the top divided by everything on the bottom. Two significant digits, that rounds to 56 grams of Fe2O3. Moles of that cancel out. Forgot to do that on my last one. Last one, if you have 2,000 grams of C8H18, how many moles do you have? Blank grams on the bottom, because I want that to cancel out. 1 mole C8H18 on the top. And I've got to add up the molar mass. 8 times 12.01. 18 times 1.008. Add that together, 96.08 plus 18.144. 114.224. Multiply across the top and divide by the bottom. Answer to, this is 1 significant digit. Yikes, I guess it would be 20 moles C8H18. All right, there you go.